This is Algebra 2, Lesson 6.5, the remainder and factor theorems. We're dividing polynomials, and we're using the remainder and factor theorems beginning on page 352 in the textbook. Two definitions to start off. First one is polynomial long division. Back in like third grade or fourth grade, you learned long division. You did it for a while, you got good at it, and then you quit doing it because it was long and it was tedious. We're gonna kind of expedite that and do it a little bit faster. We're gonna learn the fast way to do it, and then turn right around and learn the short way to do it. But just like you divide 83 by the number 2, and you use long division to do it that way, you do times 4, and then you're going to keep bringing down your zeros until you get an exact amount. We're going to do the same thing, but we're going to do it with polynomials, which means we're not just going to multiply it or divide it by 2. We'll divide it by like x minus 2. So we're going to look at today. The second definition is synthetic division. This is that part where it's going to get much faster and much quicker. This is the key to synthetic division. X minus k. What that means is you need to understand that that's the opposite value. And you'll see that in just a minute when we do synthetic division. Once you learn synthetic division, you'll never do the long division method again. However, you still need to know how to do it just in case you get stumped on the synthetic division part. Okay, this is the first one. This is long division. It says to divide this polynomial right here, 4x to the fourth, minus x squared minus 18x plus 8, all four of those terms, by this polynomial right here, x squared plus 2x plus 3. First off, you're going to divide everything that I underlined in red right there by the first term, x squared, and that's what's happening on this first line here. 4x to the fourth is being divided by x squared. Negative 8x to the third. Is that because I was bad with it for a minute? Okay, we'll get this figured out in a minute, but negative 8x to the third divided by x squared. Again, still dividing by the same polynomial or by the same x squared, and then 3x squared divided by x squared. So when you divide each one of those, you do it just like we did on the bell work. 4x to the fourth divided by x squared gives you 4x squared. You just subtract 4 minus 2. Negative 8x to the third divided by x squared, you just subtract x to the third minus x squared. You get negative 8x to the first power. And then 3x squared minus divided by x squared, you're going to do 2 minus 2 to give you 3x to the 0 power, which gives you 3 times 1. So now you have 4x squared minus 8x plus 3. And what you're going to do, just like the old long division method, you're going to take this term and you're going to multiply it by each one of those terms. So 4x squared times x squared. You're multiplying the same bases, and that's why you get 4x to the fourth. You're going to take this same term and you're going to multiply it by that. 4x squared times 2x. And notice that's why this is called, again, long division. 4x squared times 2x is 8x to the third. You add x squared plus x to the first power. And then 4x squared times 3 is going to be plus 12x squared. Now what you do is you subtract, again, just like long division, you subtract all of these numbers. Okay. 4x to the fourth power minus 4x to the fourth power cancels that part out. That part's gone. 0x to the third power. And again, this is going back to where it says use 0 as a coefficient of x to the third power right here. 0, it's none is represented, but it still has to be in there to hold a place. 0x to the third power plus 8x to the third. But it's not plus because you're subtracting this entire line. So it's like 0 minus 8. That's why we get negative 8x to the third. Then you have negative, and it's going to be negative 1 since there's nothing shown there. Negative 1x squared. Because right here, this was negative 1x squared. Minus 12x squared. Again, minus is out front of all of them. So negative 1 minus 12 is negative 13x squared. So right there, you're finished with that. Then again, just like long division, you bring this one down. You just keep bringing down the next digit. So now you have negative 8x to the third minus 13x squared minus 18x. And then you multiply the next term by it. So we're getting 4 times 2x now. So let me erase all of this just to show the next step. 4x squared times now this one. 2x is going to be 8x squared. Did it times the wrong one. I apologize. This one. There we go. Now we got it. Negative 8x squared times x squared. The next one times x squared is negative 8x squared. Negative 8x squared times 2x is negative 16x squared. I said squared a second ago. I meant to the third power. And negative 8x squared times 3 is going to be negative 24x. And I keep saying x squared over and over. I'm not sure why. Again, this is why this is called long division, because it gives you chances to make tons of mistakes. Again, this is minus. So now what it gives you is minus a negative, all of those, which turns into plus. That's why this one cancels out. Negative 13 plus 16 is going to be positive 3x squared. And negative 18 plus 24 is going to be positive 6x. So you have 3x squared plus 6x, and then this one comes down plus 8. Again, long division. We have one more thing we have to multiply by. We multiplied by the first one, and we multiplied by the second one. Now we're going to multiply on the last one by 3 for each of these. Okay? So 3 times x squared is 3x squared. 3 times 2x is positive 6x, and 3 times 3 is 9. So again, we're going to subtract them here. 3x squared minus 3x squared, again, is going to cancel that out. 6x minus 6x cancels that out. And then 8 minus 9 gives you a remainder of negative 1. So your remainder is going to be everything that's at the very top, 4x squared minus 8x plus 3. And again, that's just taking this part here and then putting the remainder plus negative 1 over the original thing that was the numerator. And again, I know this is extremely tedious. Watch when we do synthetic division. It's going to get much better. X squared plus 2x plus 3. So it goes back over that. In fact, we're not even going to do this example right here. We're going to go right to the remainder theorem, and we're going to work on synthetic division. It says if a polynomial, you read that, f of x, is divided by x minus k. Again, this is what I told you a little while ago. When you see minus right there, think of the opposite term. That's what the minus means. The remainder is going to be r equals f of k. So what that says is, using synthetic division, divide x to the third plus x squared minus 5x plus 3 by x plus 2. Remember, this is your x minus k. You want the opposite of this. So the opposite is negative 2. So in order to use synthetic division, we're going to set up something that looks like this. Okay, it looks real funny at first, but it's very easy. All this is this term out front is your k value. So since it was positive 2, we write negative 2 right there. Then all of these numbers here, 1, 1, negative 5, and 3, represent each of these coefficients. This one's 1, so this one's 1. This one is 1, so this one's 1. This one's negative 5, so this one's negative 5. This one's 3, so this one's 3. That's where those numbers come from. So from there, bear with me still, from there, it's way easier than it looks. All you do first is you bring this first number down 1. You bring that number down 1. Now where the next number comes from is you multiply that 1 times that negative 2. And that's where this negative 2 comes from. Then you combine 1 and negative 2 to get negative 1. Again, you multiply it back by that number, -2. -1 times -2 gives you +2. You combine -5 and 2 to get -3. Again, I know this looks very new, but it's very, very easy when you do a couple of them, I promise you. -3 times -2 again is +6. And then you combine 3 and 6 to get 9. So that's where all of these numbers come from. From there, you go 1 degree lower than what you started with. What we mean by 1 degree lower, it started at x to the third. So each one of these represents a coefficient. We're going to go one smaller than x to the third. And this one's going to be x squared. Then we're just going to count down. This is going to be x to the first power. Then there is no more x coefficient. Therefore, this one is your remainder. And watch what we have. So x to the third plus x squared minus 5x plus 3 divided by x plus 2, that's what we did, is this 1x squared, that's this, minus 1x, this, minus 3, and the remainder is 9 back over the original denominator, x plus 2. Okay, it's going to make more sense when we do a couple more examples, I promise. I know it looks like something you've never seen before because it probably is. Okay, we're going to do the first one together. We're going to divide x to the third minus x squared minus 2x plus 8 by x minus 1. So if I want to write synthetic division, I'm going to write it like this. What number am I going to put right here? What is the opposite of what I have up there? It says -1 right there. So what do I put? +1 goes right there. Now, what am I going to put in all of my coefficient slots? Okay, the first one is going to be 1. So right here, 1. The next one is going to be what? -1. The next one's going to be what? Negative what? 2. And the last one's going to be what? 8. So those are the numbers you're going to put. From there, we're going to fill the rest of them in. I'm here, and you just bear with me. This one comes straight down. You don't do anything with that one, 1. Multiply that 1 times the denominator, or that k value we got, 1, this one here. We're going to keep going back to that one. 1 times 1 gives us 1. When we combine these numbers, what happens when we combine -1 and 1? What do we get? 0. When I multiply 0 back times this one, what do I get? 0. When I combine -2 and 0, what do I get? -2 and 0, when you add them, is -2. When I multiply that back times 1, what's -2 times 1? -2. When I combine 8 and -2, what do I get? 8 minus 2 is what? 6. Those are the correct numbers. We got all of the correct numbers. From there, all we have to do is write in the correct exponents or the correct x values with their exponents. You go one smaller than what you start with. So instead of saying 1x cubed, I'm going to have 1x to the what power? Second power. Okay. Plus or minus 0. There's no reason to write this in, but we'll write it in just to hold the place for a second. Plus 0. What's the next smallest degree? It was x squared, then it's x to the what? First power. So plus 0x minus 2, and that's where it's going to be no variable term. And then it's going to be plus 6 over the original denominator, which was x minus 1. So right here, there's no reason to write 0x. So what we have is x squared minus 2 plus 6 over x minus 1. Okay, take 1 minute and see if you can make heads or tails out of the other one, divided by x plus 2. You're going to use everything the same except the x plus 2 part. We'll come back in 1 minute. All right, first thing, what am I going to put as the number we're going to divide by the whole time? -2. Remember, it's the opposite of whatever you see. So since it says +2, -2 goes there. What are we going to put for each coefficient? We're going to use the same ones we used a minute ago. We're going to use 1. We're going to use -1. We're going to use -2. And we're going to use 8. Now, one thing you need to check, and one thing none of these examples are showing, is you need to make sure every degree is represented. If you think back to example number 1 where we did that long division one, it said to use zero's coefficient as x to the third since there was no x to the third. You have to make sure x to the third is represented, and that's probably why I got stumped on that one part. You got to make sure it's represented. All of your degrees are represented. They have 3, then 2, then 1, and then none. So right here, we're going to do the same thing. This first 1 is going to come straight down. You're going to multiply it times -2, and you're going to get -2. When you combine those two, you're going to get what? -3. Just going straight down. So the column right above it, -1 and -2, gives you -3. Now is what you were trying to say. -3 times -2 gives you the 6 you were talking about. When you combine those two, -2 and 6, you get what? 4. And when you multiply 4 and -2, you're going to get -8. A lot of times it's going to come out to be just like this. A lot of times you're going to get where it's going to be 0 when you combine 8 and -8, because what that represents is there's no remainder there. So all you need to do is go back to your original one, and all you're looking for is its degree, x to the third power. You're going to go 1 less than that. So it's 1x squared minus 3x to the first power plus 4, and there's no x values, and there's no reason to write plus 0 over x plus 2 because there is no remainder. This is the trinomial for that. X squared minus 3x plus 4. Okay, the factor theorem says a polynomial f of x has a factor x minus k if and only if for, y'all remember that from geometry, if and only if f of k is equal to 0. What that means is that when you plug in the number 5 right here, f of 5, you get 0. When you cube 5, that gives you 125. Minus 19 times 5, minus 30, all of that simplifies to the number 0. So it says because f of 5 is equal to 0, you know f, since it was 5, you know this one is the opposite. Again, just like earlier, you're thinking opposites. It was 5, you show -5 right there. So use synthetic division to find the other factors. Here's your synthetic division. You're going to use each one of these. Here's an example. Notice you go from x to the third. There is no x squared. Therefore, you represent x squared's coefficient with 0. So you're going to use that, the you're going to use the opposite of x minus 5, and the thing you're dividing by is 5. So 1, 0 for x squared. X to the first power is negative 19, and then they have negative 30. You bring the first 1 straight down, and you get 1. You multiply it times 5 and you get 5. You combine 0 and 5 and you get 5. You multiply 5 times 5 and you get 25. You combine negative 19 and 25 and you get 6. And you combine 6 and 5 to get 30. Notice negative 30 plus 30 gives you 0. So again, you have those coefficients. You have those numbers, the coefficients that are multiplying by it. Go one less than the degree that was given, x to the third. So you have 1x squared. So we'll write it out here to the side. This one right here, 1x squared plus this one here, 5x to the first power, plus, since it's positive, 6. And then you don't have to write plus 0 over x minus 5 because there's no remainder. So that's where this right here comes from, x squared plus 5x plus 6. When you multiply that times this one, x minus 5, it will give you x to the third minus 19x minus 30. So what we're doing is division. All multiplication and division are inverses of each other. Division is multiplication backwards. So right here you have x minus 5. Then all you have to do is factor out this trinomial right here. Just like this. Oh, the same thing like we factored out on the bell work. You just do x times x. And then what two terms get you to 6? It's either 1 and 6 or 2 and 3. Both of them work. But since you have to use the same sign because it says plus, you got to use 3 and 2. So this is the same. They're both plus. So that's where plus 2 and plus 3 comes from. So when you multiply all three of those, and we did this, we multiplied binomials, we multiplied polynomials. When you undo all of it, you get x minus 5 times x plus 2 times x plus 3. The same thing is true when you find the zeros of the problem. Okay, let's try this one last problem before we get out of here. Okay, it says, note that f of negative 4 equals 0. Okay, so you got f of negative 4. So when you rewrite that, you rewrite it opposite as x plus 4. Okay, use synthetic division to divide by x plus 4. Take about 1 minute. All right, I cut it a little bit shorter than a minute to make sure we have enough time. You're going to use the factor negative 4. Remember, it's the opposite of the plus 4. You're going to use all the coefficients, 3, 13, 2, and negative 8. And they're in order and there are none missing. So right there, this one comes straight down, 3. Times negative 4 is negative 12. 13, when you put those two together, and negative 12 is going to be 1. Times negative 4 is negative 4. 2, and when you put it together with negative 4, you get negative 2. Negative 2 times negative 4 is going to be positive 8, and when you put those two together, you get 0, so the remainder is 0. Therefore, your factor, your trinomial, will be 3x, and remember, it's 1 smaller than this one, squared, plus 1x to the first power, minus 2 with no exponent. So 3x squared plus x minus 2 times x plus 4. And then all you have to do is factor this one out. Now, I know there's a value for a, but it has to be 3x times x. 2 only has one term 2. Only has one pair 2. 2 and 1. It has to go here. 2 times 1. This tells you the signs are opposite. So we want to make a positive value. This one says the bigger one is going to be positive. So plus 1 in this case to make it 3x minus 1 minus 2. So x plus 4 times 3x minus 2 times x plus 1.